Hello everybody, I'm Heike Hoedt from Simply Solar again, presenting the SophiA project for you. SophiA is an acronym for Solar Off-Grid Solutions for Hospitals and Pharmacies in Africa. It's a Horizon 2020 project in the Africa-EU collaboration, EU-funded project lasting 4 years, and the 13 project partners are dispersed over 8 countries. They strive to provide hospital commodities, hospital infrastructure based on solar energy for rural hospitals in Africa. We're talking about safe and clean drinking water and technical water for the hospitals, hot water and steam, refrigeration for medicines and vaccines at different temperature levels, and electricity. The hospital demo sites are hosted by 4 African countries, that is Burkina Faso, Cameroon, Uganda and Malawi, where in each country one particular hospital was identified to be most suitable as demo site. The original concept of the project is to house this infrastructure in 2 40-foot containers. Here we see the cooling container, which is occupied by the cooling machinery for the different temperature levels, and the utility room. And on its roof, actually, not seen here in the picture, it has the photovoltaic energy supply. The second container is the water container, which in a bit more than half of its space houses the water treatment plants for drinking water and distilled water. And in one part it houses the solar steam generation, and on the top of the roof are again PV panels. In Burkina Faso this is around 60 kilowatt of PV. There are some technologies like the solar hot water systems which are not installed in the containers but at the usage side. And we have the PV Medport, which is an autarkic solar energy based station developed for much smaller healthcare centers in rural Africa, which are also off-grid. There are 2 versions currently implemented in the project. The PV Medport Power solution, which you see on the left side. It serves as a waiting hall, an outdoor waiting hall, shaded and rainproof, which can be connected to an existing dispensary, for example, or a health station of any kind, to provide electricity to that health station. And there is the PV Medport Pharmacy. It will be implemented in Cameroon and Malawi, which is an autarkic pharmacy with the different temperature requirements. For example, the whole housing is climatized to 25 degrees because of storing medications, and it has a solar powered refrigerator for vaccine storage, and of course internet connection, lights, all you need for a pharmacy. Here you see impressions from the first SophiA installation that took place in 2024 in Burkina Faso. You see one of the containers with the PV on top. You see the solar direct cooking solution with 2.5 square meter Scheffler reflectors. 2 of them are installed for the hospital kiosk, which provides for patients' relatives who want to purchase a snack or a small meal. And the bottom left you see the PV Medport Power installed at 30 kilometers from the hospital in a governmental health center with a maternity where it provides electricity. And the bottom right photos are the institutional cooking solution based on photovoltaics, which I will present a little bit later in more detail. The PV Medport is an installation with 2 kilowatt peak of PV with batteries, and it is coming in pieces, so it's like a kit, can be easily transported and installed within 2 hours. The roof has a aerodynamic shape that allows to install this without foundations, because when the winds increase, the aerodynamic design will make sure the roof is sucked down and pushes everything towards the ground. I want to particularly highlight the PV steam cube because it's much related to the topic of this conference. The PV steam cube is a PV powered storage unit plus steam generator. It's a metal core that is heated with electric resistors that are integrated into it and stores energy from PV electricity in form of heat up to 400 degrees, and on demand by switching on a pump, water can be injected into the heat exchanger pipework that is integrated into the metal core and thus generates steam on demand for whatever application you have. In the hospitals, this is cooking and hospital laundry at the hospital in Burkina Faso, and it is autoclaving and cooking in Cameroon and Malawi and Uganda. It means that this PV steam cube is not a solar cooker, it's a steam generator which can be used for solar cooking, for institutional solar cooking, plus it can be hooked at the same time to various different applications. Here you see the setup in our own workshop, which is, I show you this because it shows the different parts of the PV steam cube installation, which are in reality in separate rooms. In the middle, this gray box is a PV steam cube, very well insulated metal core. You see the black cable where the PV electricity goes in, and you see this well insulated pipe where steam is extracted. Here in this case, it is the setup we later installed in Cameroon. So it has two double wall steam cooking vessels of 40 liters each. Here you see the operator panel that is located in the kitchen. In the background you see the autoclave hooked to the other side of the steam cube. This is the view from the other side, so you get a better picture of the small autoclave. And on the right you see it in operation. In Burkina Faso, the PV steam cube is from aluminum, weighs about a ton and stores 40 kilowatt hours of energy. It is installed inside one of those containers. Then there's pipe work that go to the kitchen. We had to use an existing corner of a kitchen building, so it's a bit crowded, but the installation can cook for about 80 staff, patients, and poor participants of medical campaigns. The interesting conceptual part here is that the PV steam cube is integrated into the complete PV system of the whole infrastructure the SophiA project provides. It serves as a buffer storage unit that makes the whole system more efficient because it can be charged at any time. So that means whenever, for example, the electric batteries, which are also there for the container equipment, are full and there's not much electricity demand from any other side, then this is not wasted, but it can store in the PV steam cube. And the PV steam cube will give steam 24/7 on demand. If you leave it alone, it will even store the energy for several days. Here in Cameroon, you see how this little container has the kitchen integrated into it, so it's a little bit a different concept than what was installed in Burkina Faso. In Cameroon, the system was sized down to fit better to the exact need of the rural hospital. The water treatment is in one side and the other side was modified into a kitchen. Here in this door we have what is seen below, the autoclave and the steam cube, and on the left of that is the kitchen. I have only photos under construction for the moment because it hasn't been fully commissioned yet. In the hospitals in Uganda and Malawi, we have a situation that's very common in African rural hospitals. That is, the hospital provide a shed to the patient's relatives who are there with the patients, and they cook on their own account for their sick relative. So the hospital is only basically providing some walls and a roof. Here you see several 3-stone fires. People bring their own cooking equipment, bring their own fuel, and do sort of semi-open air cooking here. And our idea there is that this will be transformed into an institutional kitchen which does a centralized catering for the hospital, using the same technology, the PV steam cube and the double-walled steam vessels. The SophiA containers for Malawi and Uganda are also adapted slightly. That is the learning curve of the project. They're sized down in order to be more economically viable. In Cameroon even we singled out the refrigeration solution by using solar direct drive devices, which are autarkic devices powered by their own PV panels, each of them. This way we don't need the refrigeration container. I want to highlight that particularly the PV steam cube is a novelty that was designed in the framework of the SophiA project, and here we present it basically for the healthcare sector, but it can find its applications in food processing industries, agricultural industries, and so on. Thank you very much.